Hello everyone, hope you all are doing good. In today's topic, we are going to discuss about in vitro anti-haemorrhagic action of phosphorus in 6, 30, 200 and 1 potencies. This particular project was my post-graduation dissertational project and Dr. Pravas Kumar Pal was my guide. This project was aiming to find out how phosphorus acts on hemostasis. We all know phosphorus is a very good remedy in controlling hemorrhage, but we don't know on what phenomenon it controls the hemorrhage. We know that hemorrhage has too many factors which is involved in it. So this particular study works on finding out on what aspect of hemorrhage does the phosphorus act to control it. So this is one aim of the study. Another aim of this particular work is to find out which potency works better in what form of action. So these are the considerations taken into this particular project. The project was done in the year 2013 to 2016 as a post-graduation dissertational project, and it was granted by Father Muller Charitable Institution by 50% grant. The methodology of this particular study is 15 volunteers were selected who are healthy, whose hemoglobin, TC, DC, ESR, platelet count as well as bleeding time and clotting time was perfectly normal without any traceable coagulopathies was taken into this particular study. Only A positive, B positive and O positive blood groups were taken. Negative blood groups were not taken into consideration. This particular project was designed in such a way that it is a complete in vitro work where the blood sample will be collected from the volunteers and it will be added with the medicine or the control and it will be taken for the test purpose. So 5 tests were taken for considerations in this study. Out of it 4 were done in blood and 1 was done with milk. The 4 tests done in blood are blood coagulation test, plasma recalcification time, activated partial thromboplastin time and prothrombin time. These are the 4 tests done in blood, and milk precipitation test was done in milk. So considering these 5 tests as the parameters, we investigated how phosphorus acts against the bleeding. 15 volunteers were taken for this particular study. From these 15 volunteers, the blood samples was collected in a span of 3 weeks gap and 10 ml was collected per sitting. The blood sample thus collected were subjected to analysis under 6 groups. First is distilled water group, second is dispensing alcohol, third comes phosphorus 6, then phosphorus 30, phosphorus 200 and phosphorus 1. Each test was repeated thrice and the average value was taken into consideration. The blood coagulation time procedure was 0.1 ml of drug or the control was taken in the test tube and it was warmed in water bath for 1 minute, followed by addition of 0.5 ml of blood into the test tube. The time taken for the coagulation was noted using timer. For the prothrombin time, 0.1 ml of plasma was taken and 0.01 ml of drug or control was added to it. It was incubated for 1 minute at 37 degrees Celsius, followed by 0.2 ml of calcic thromboplastin was added and the coagulation time was noted. For the activated partial thromboplastin time, 0.1 ml of plasma was taken and 0.01 ml of drug or control was added to it, followed by addition of 0.1 ml of cephalin in 1/10 dilution and then 0.1 ml of CaCl2 was added to it. The time taken for the appearance of the clot was noted. In plasma recalcification time, 0.2 ml of plasma was taken and 0.01 ml of drug or control was added to it. The sample was incubated for 1 minute in 37 degrees Celsius, followed by 0.1 ml of warmed M/40 CaCl2 was added to it. The time taken for calcification was noted using timer. For the milk precipitation test, 0.01 ml of drug or control was taken and 0.1 ml of milk was added to it. 3 minutes it was allowed to stand and then the sample was centrifuged at the rate of 3000 revolutions per minute for 1 minute. The presence or absence of pellet formations were taken into consideration. The result obtained for this particular blood coagulation time test was, for distilled water, it took 32.36 plus or minus 0.80 and for dispensing alcohol 2.66 plus or minus 0.84, for phosphorus 6 2.91 plus or minus 1.13, for phosphorus 30 0.76 plus or minus 0.36, for phosphorus 200 1.16 plus or minus 0.31, and for phosphorus 1m 1.27 plus or minus 0.46. As these values were statistically significant according to ANOVA, post hoc test was done and it indicated that phosphorus 30 is significantly able to reduce the coagulation time in comparison to all other groups. Distilled water prolonged the coagulation time, probably it is due to the dilution effect of distilled water. The recordings were as follows for plasma recalcification time. For distilled water, it was 5.12 plus or minus 0.19. For dispensing alcohol, it was 3.46 plus or minus 0.28. Phosphorus 6, it is 3.29 plus or minus 0.05. For phosphorus 30, 3.62 plus or minus 0.20. For phosphorus 200, 3.05 plus or minus 0.04. And for phosphorus 1m, 4.04 plus or minus 0.24. As this was also statistically significant, post hoc test was applied and phosphorus 200 was found to be statistically significant to lower the coagulation time compared to the other groups, especially in comparison to the dispensing alcohol group. In regard to the prothrombin time, the values are as follows. Distilled water took 3.40 plus or minus 0.07 and dispensing alcohol took 15.84 plus or minus 0.25. Phosphorus 6 took 8.68 plus or minus 0.80. Phosphorus 30 took 2.37 plus or minus 0.06. And phosphorus 200 took 3.14 plus or minus 0.06. And phosphorus 1m took 1.47 plus or minus 0.05. Considering these values, via post hoc test, it is understood that alcohol prolonged the coagulation period, but phosphorus 1m, in spite of having alcohol content in it, it was able to reduce significantly the coagulation time. In activated partial thromboplastin time, the time taken by distilled water was 0.53 plus or minus 0.03. For dispensing alcohol, 1.15 plus or minus 0.08. For phosphorus 6, 1.14 plus or minus 0.18. Phosphorus 30, 1.20 plus or minus 0.19. For phosphorus 200, 1.12 plus or minus 0.26. And phosphorus 1m is 1.16 plus or minus 0.29. Similar to alcohol, all the other groups were having the values. The distilled water group reduced the coagulation time, but as dispensing alcohol was considered as the standard control here, there was no much significant variation between the groups noticed. So this is the understanding of all the tests which was conducted in the blood. In regard to the milk precipitation time, the result obtained was actually not so clear because alcohol itself caused coagulation. So the pellet formation was not appreciable in this particular process. The overall conclusion derived in this particular work is phosphorus is able to lower the span of coagulation by three phenomena. One, it reduces the blood coagulation time, especially phosphorus 30 is able to do that. And the second is prothrombin time. Prothrombin time is significantly lowered by phosphorus 200. And the last is plasma recalcification time, which is significantly lowered by phosphorus 1m group. There was no significant action noticed in activated partial thromboplastin time, and the other phenomenon is astringent property, which was investigated by milk precipitation test, where we couldn't find any significant result. For the further work, this same project can be continued in a in vivo model, that is one way. And the second one is the milk precipitation test can be redone with the potencies prepared from the distilled water. So this is the work. Hope it was interesting and useful for you. Meet you all again with another interesting research. Take care.